welcome to my channel Math Made Easy. In the previous videos I solved section A and section B. I'm going to provide the links in the description box. In this video we'll start with section C. Look at the 26th question. In triangle ABC, D, E and F are midpoints of BC, CA and AB respectively. We need to prove that triangle FBD is similar to triangle DEF and triangle DEF is similar to triangle ABC. Okay. If you see here, triangle FBD is this triangle FBD and triangle DEF here. So we need to prove that these two triangles are similar. So if we can prove at least two of these triangles are equal, then by a rule of similarity we can tell that these two triangles are similar. Okay. So in grade 9 we learnt about the midpoint theorem, right? So if a line segment joins the midpoints of any two sides of a triangle, then that line will be parallel to the third side. So here F is the midpoint of AB and E is the midpoint of AC of triangle ABC. So FE is parallel to BC and FE is equal to half BC, right? So from midpoint theorem we can write FE is parallel to BC and FE is equal to half BC. Right, FE is parallel to BC means in turn FE is parallel to BD also and FE is parallel to CD also, right? And FE is half of BC means FE is half of BC means since D is the midpoint of BC, so FE is equal to BD. So from this we can write FE is parallel to BD and FE is equal to BD, right? So this is from midpoint theorem. Okay, so since FE is parallel to BD and FE is equal to BD in a quadrilateral, if one set of opposite sides are both parallel and equal, it is a parallelogram. Therefore, EFBD is a parallelogram. Right? So since CFBD is a parallelogram, we can tell that opposite angles are equal. So let us say this is, that means angle B of this triangle, let's say this is angle 1, should be equal to angle E. Let us say this is 2. And if it, if we take EF parallel to BD, then FD being transversal, alternate interior angles are equal. Angle F of triangle DEF should be equal to angle D of triangle FBD. So since we got two angles are equal, so by a rule of similarity we can tell that these two triangles are similar. Let us say this is angle 3 and angle 4. That's all. So consider in triangle FBD, in triangle FBD and triangle DEF, angle 1 is equal to angle 2 since opposite angles of a parallelogram are equal. And we proved that EFBD is a parallelogram here. Opposite angles of a parallelogram are equal. Then angle 3 is equal to angle 4. FBD here, so angle 4 is equal to angle 3 of angle DEF. These are alternate interior angles. Since two angles are equal, by a rule of similarity, we can tell that triangle FBD is similar to triangle DEF. So this proves our first part. This one is done. Now look at the second part. Triangle DEF is similar to triangle ABC. So we have DEF here. And we need to prove that that is equal to, that is similar to ABC, this triangle. Okay, so from this triangle we already have angle 1 is equal to angle 2. If you say angle 1 is angle B of triangle ABC, angle 2 is nothing but angle E of triangle DF. We already got one angle equal, right? So if we consider triangle, okay, and also what about the other angle? We have FE parallel to BC, that means FE is parallel to DC also, right? So since FE is parallel to BC, FE is parallel to BD, sorry, DC. FE is parallel to DC, and FE is equal to half BC means since D is a midpoint, we can also tell EF is equal to, or FE is equal to CD or DC. Since EF is parallel to DC and EF is equal to CD, again in this quadrilateral, one set of opposites are parallel and equal. Therefore, EFCD is a parallelogram. So it's a parallelogram. So again, opposite angles are equal. So angle 3 of this triangle should be equal to angle C of this triangle. Let's say this is angle 5. We already got one set of angles. Angle 1 and angle 2 are equal, and angle 3 and angle 5 are equal. Therefore, by a rule of similarity, these two triangles are similar. So in triangle DEF and triangle ABC, angle 2 of triangle DEF, so angle 2 is equal to angle 1 of triangle ABC. These are equal. These are basically opposite angles. We have already written here opposite angles of this parallelogram. Opposite angles of this parallelogram. Then angle 3 of DEF, which is angle DFE, is equal to angle 5 of ABC, which is ACB. Angle 3 is equal to angle 5. These are also opposite angles of parallelogram of EFCD. These are opposite angles of EFBD, right? Therefore, by a rule of similarity, we have triangle DEF similar to triangle ABC. So hence prove the second part as well. Hope this is clear. We are just using the midpoint theorem first. Since E and F are midpoints of sides AB and AC, then the line segment joining these midpoints will be parallel to the third side and equal to half of the third side. Therefore, FE is parallel to BC and FE is equal to half BC. Since D is on point BC, as FE is parallel to BC, FE is parallel to BD also, and FE is equal to half BC means since D is the midpoint, here BD is equal to DC. Here half BC is equal to BD, that is equal to DC. So I am replacing half BC with BD here. Since one side of opposite sides are parallel as well as equal, this is a parallelogram. Since it is a parallelogram, then opposite angles are equal. So we can tell angle 1 is equal to angle 2. And since they are parallel, and if we take FD as a transversal, angle 3 and angle 4 will become the alternate interior angle. Since we have two angles, by a rule of similarity, we can tell that these two triangles are similar. Similarly, EF is parallel to CD and EF is equal to CD. Therefore, EFCD is also a parallelogram. Opposite angles, angle 3 and angle 5 are equal, and this side angle 2 and angle 1 are equal. Therefore, by a rule of similarity, these two triangles are also similar. Hope this is clear. Let's move on to the next part in the same question. In triangle ABC, P and Q are points on AB and AC respectively, such that PQ is parallel to BC. We need to prove that median AD drawn from A on BC bisects PQ. That means what we need to prove? We need to prove that PR is equal to QR. So that implies that AD bisects PQ, right? So let's write first what is given and what we have to prove. See, what is the data we have? We have PQ parallel to BC, right? Since PQ is parallel to BC, so from midpoint, from basic proportionality theorem, what we can write? Since PQ is parallel to BC, P and Q divides AB and AC proportionately. So we can write AP by PB is equal to AQ by QC, or we can also write AP by AB is equal to AQ by AC. Okay, let's keep this as a, let us say this is a relation 1. We'll write step by step later. I'm just giving the overall concept here. Next, we also have your R is lying on PQ. So if you consider triangle APR and triangle ABD, if we consider triangle APR and triangle ABD, can we prove these two triangles as similar? Angle A is common in both the triangles. Since PQ is parallel to BC, PR is parallel to BD as well, right? So angle P and angle D are corresponding angles. So corresponding angles are equal when the lines are parallel. Similarly, R and D are also corresponding angles, right? Therefore, APR is similar to ABD. So we can write the corresponding sides proportion. We can write AP by AB is equal to PR by BD, which is equal to AR by AD. We'll consider any two sides relation as per our requirement. We want PR R cube. So let us say we want this one PR by BD and AP by AB. So we may not need this one. Okay, so AP by AB is equal to PR by BD. Let us say this is a relation 2. Similarly, we can prove triangle ARQ is similar to triangle ADC. Since RQ is parallel to DC, R and D are corresponding, Q and C are corresponding, and angle A is common. So triangle ARQ is similar to triangle ADC. So from this what we can write? AR by AD is equal to RQ by DC is equal to AQ by AC, right? Since we have this data AP by AB is equal to AQ by AC, we already got a relation AP by AB here. So we need AQ by AC and we need to prove PR is equal to RQ. So definitely we need RQ. So we need this. So we don't want this relation AR by AD. So let's not take this one. Now let's say this is a relation 3. Now see, from 2 and 3, AP by AB is equal to PR by BD and RQ by DC is equal to AQ by AC. But from 1 we have AP by AB is equal to AQ by AC. That means so AQ by AC is here, AP by AB is here. That means these two are equal. PR by BD is equal to RQ by DC. But AD is a median. Since it is median, it bisects the opposite side BC. That means BD and DC are equal. Since these are equal, we can cancel them, or we can replace BD with DC or DC with BD, then get cancelled. Then PR is equal to RQ. That's what we need to prove. Therefore, it implies that AD bisects PQ. Alright, now write. So, it's PQ is parallel to BC we have, and AD is median. AD is median, it implies BD is equal to CD. Now what we need to prove? We need to prove that AD bisects PQ. That means we need to prove PR is equal to RQ or PR is equal to QR. Proof. Since PQ is parallel to BC, AP by AB is equal to AQ by AC. From basic proportionality theorem from BPT, let us say this is a relation 1. Then we have triangle APB, so APR, similar to triangle ABD. It implies AP by AB is equal to PR by BD. Take this is a second relation. Similarly, triangle ARQ is similar to triangle ADC. So from this we can write the corresponding sides proportion. AQ by AC is equal to QR or RQ by DC. Let us say this is relation 3. Now from 1 we have AP by AB is equal to AQ by AC. Therefore from these two are equal. Since AP by AB is equal to AQ by AC, since LHS are equal, we can equate the RHS. So from 1, 2 and 3, from 1, 2 and 3 we have PR by BD is equal to RQ by DC. But BD is equal to DC since AD is median. AD is median onto BC. Therefore, PR is equal to RQ. It implies AD bisects PQ. Hence proved. Hope this is clear. So we are going to continue the next questions in the next video. If you have any doubts, please do mention the comment box. I'm happy to help you out. Thank you.